Hello everyone, welcome back to our adventures. Today's video, we will solve the polymorphic challenge from ImaginaryCTF. It was a 300-point reversing challenge. Let's start by checking its file type. I'm going to use Rabintu for that. And we can see that it is a 64-bit ELF binary, which means it is a 64-bit binary for Linux. So let's open it with binary ninja for disassembling it. And we can already see some funky stuff going on. So let's start analyzing. So the first instruction itself, which is an XOR, it grabs the address of the instruction which is next to it and it XORs it with some constant value, which means that the instruction that we are seeing, this sub rx something, is actually garbage and it will be decrypted in the runtime. And we can also see that this same pattern is all over the binary. So which means that this binary will unpack itself or maybe decrypt itself in the runtime. And in reversing terms, this is known as self-modifying code. So the binary is modifying its code in the runtime. So how can we solve this? So the first instinct to solve this was, I thought I can write a disassembler which can like emulate it or decode these instructions and give me the disassembly. For that, I used the Capstone library for Python. It has bindings for Python. And I did the same thing. I was just looking for these XOR instructions and grabbing the address and XORing it with that and writing it into a file. So the results that I got was this. So it was not perfect. I looked at it, but it was not giving me any hints on how to solve it. And it broke at some point. It worked here till here, but then it broke and gave the same instruction. So I didn't bother looking more into it because I found an easier way to solve this. For showing that way, I have to pop up my Linux VM. Okay, so this is my Linux VM. I have copied the binary over to my VM. So let us run it under a debugger and I'll tell you why. So what my initial thoughts were that I will just let the binary run till the end and then dump all of the instructions, because in the runtime it was decrypted itself. So I thought like I will just dump all of the instruction and then start analyzing from there. But I found something really interesting. So let us just run the binary and now it is waiting for my input. So let me give anything like for example Q, and the binary actually seg faulted at some address and this address will be helpful later. So I'll just copy it into my notes. Yeah, so the binary seg faulted. So what my educated guess was that the binary was decrypting itself based on our input. So if we gave it correct characters, it will decrypt it to correct instructions and the execution will go on. But if we give a wrong character, it will decrypt it into garbage and it will just segfault. And I am sure about that because we already knew the flag format, which was ICTF, opening brace and some characters and the closing brace. So I tried the first character, which was I. So if I give I, it still segfaults, but the address is different. If we look at it, the address is 10A and previously it was 0B6, which means it decrypted some more instructions and segfaulted further. Then I started experimenting it with and I gave it IC and we can see that it segfaulted even further. So now we know that we can just brute force the flag byte by byte using a debugger and looking at the segfault address. For that I wrote a simple Python script which did the same. The start address is the same that we got the first time we ran the binary, and then character by character what I did was I was writing a GDB script to the Linux VM and then I run the process under GDB. Then I was just grabbing the line segfault and then grabbing the address and comparing it with the start address. If this address that we got while running is greater than the start address, then we can say that we have found a correct character, and I'm just printing the address and the flag. So let me run this script over on the VM and let us look at the output. So I have copied the script to in the Linux VM and let me just run it. Script under Python. And because this is doing a lot of operations, it will take some time. So I'll just pause the video and resume when the execution has completed. So the execution of the script has completed, and we can see that character by character it actually decrypted the whole flag for us. So let us try to check if the flag that we got is correct. So I'll just run the binary and provide the flag that we got, and it says it is correct. So as you can see that how easy it is to just script GDB using Python. Uh, I actually use the subprocess module for that, but there are actually some libraries which allow us to directly import the GDB module and then run it. So we just wrote around 50 lines of code and decrypted the flag byte by byte. So that's all for the video. Thank you for watching. Keep hacking and stay awesome.